All right. It is 1:15, which I believe is our start time, right? Is that supposed to be? Yeah. All right. So everybody, take 30 seconds, decompress. How's your stress level? See this? I like this guy over here. I like this guy. What's stress? That's fantastic. Well, that's kind of what I was thinking. Take a minute and like release the whatever about the snow days and the craziness, and let's settle into allow yourself some time to engage in your own learning for right now. Mike and I have tried very hard to make this relevant to you guys, so I hope you enjoy yourselves over the next little while. Our purpose is what it's always been, but today specifically, we decided to shift a little bit from, we've kind of worked on some mathematics knowledge up to this point, and here are some tools that you might use, but we really haven't attacked what knowledge you might need to implement the work. I mean, yeah, we need the mathematics too, but there's more to it than that, and we're going to explore that a little bit as we go on today. Those are the outcomes we have listed, and we've listed them from the very beginning, but the two we're going to work on today specifically are those. We're going to give you another example of a task. You're going to engage in a task that you could use in your classroom, because Mike and I believe that we want to give you things that you can use. But then we're also going to talk more specifically about ways to structure mathematical discourse that might be productive, if you will. It's a busier agenda, so I'm going to try and move through this fairly quickly, so I apologize if I seem like I'm being brusque, but I want to make sure we're getting to the things we want to talk about. A quick review of where we've been. We're going to have a card sort activity for you that is potentially useful for you in your classrooms, we'll see. And then we're going to spend some time talking about the thinking that's necessary to prepare for these and anticipate what students are going to do, and then support them as they engage and do the work. And then in the end, the way Mike and I structured this is based on some research on mathematical knowledge for teaching, so we'll talk about that. And then I have a very special challenge for you guys that I'll give you at the very end, and then the usual planning and filling out your implementation guides at the end. What questions might you have about the work today? If you have a concern, by all means, phrase it as a question, and we can move forward with that as well. Gesundheit. Hearing none, okay, then I'll consider that to be. All right. So, the first time when I was not here, you guys looked at these. Well, they're all equations, right? So you looked at those equations, and now think back to that. This is where we've been, right? And answer this question for me. You have to choose one of the three words in brackets. Do variables sometimes, always, or never actually vary? Think. And share at your table when you're ready what you think. Who might be willing to share your group's consensus? Sometimes, always, or never? We could do a vote if you guys want to do it that way. If you guys are scared, it's okay. It's okay if you're scared. I understand. It's difficult to put yourself out there, but you're putting your group out there, not you. So that's a benefit. Go ahead.
We wanted to say always or most of the time, so we then lean towards sometimes, but then in the end kind of got back towards always.
In the end, kind of got back towards always? Okay.
Our answers vary.
Your answers vary, all right? I like that. I like that. So here's the question. Does anyone either agree or disagree with that particular assessment, and why?
What was the assessment?
The assessment was they settled on variables always vary.
We said sometimes, and the only reason we were just looking at that second example up there, for that second one, like there's only one answer for the second. So sometimes the variable could be more than one answer, but for that one, there's one answer.
Thoughts?
And I said for the second one that x could be a 3, but then we'd have to change the equal sign, which would mean that yeah, so.
Say that
Interesting.
again. You said that it could be what?
That x could be a 3,
Right.
but then that equal sign would be an equal sign. We'd have to change the sign.
Yeah, that's kind of where we concluded, well, x can really be anything, but there's only one that's right for that particular answer. But x could be 17, it just would be a false statement.
Right, you know, definition. You know,
And we can debate about this. The point of this was to get you guys re-engaged with this activity very shortly. I would lean toward the sometimes, simply because I like that second one as an example of, in that specific case, the value of x that makes that statement true is not a variable value. There is one specific value for it. The reason we chose those, not to say we chose those, they're from an article that talks about those are 5 very distinct ways in which we use variable without actually saying that to students. Right? Variables used distinctly differently in every one of those ways, and sometimes they vary and sometimes they don't. And that's a challenge. For instance, so let's take this one down here. Y equals kx. Does k actually vary in a given situation? Not usually, right? K is that constant of proportionality that we figure that out based on the situation, and so it doesn't vary in that case. K is a parameter in that case, not a variable, and so it's a complex kind of thing. Now, this leads to some different conceptions of algebra that we talked about as well. There's different ways of viewing algebra, and those are 4 of them. And our goal has been to give you guys experiences that try and broaden what we might traditionally have thought of, whether it's generalized arithmetic or the study of structures. I mean, it all depends. Ideally, we want a conception of algebra that kind of takes all of those into account. So, that's where we've been, and we've examined some tools to do that. And the activity we're about to do with this card sort kind of tries to take into account all of those tools. So, I would like you to read the directions, and then I want you guys to share the directions with a partner to make sure you guys understand, and we'll talk about questions. What's that? Yeah. All right, before you get too carried away with actually doing the task, what questions might you have about the directions? Because they are not exactly the clearest set of directions I've ever written. I'm aware of this.
How many rows?
That is deliberately left out because they are pairs, but technically there's a third card that is missing from each pair. And you're going to have to recreate it. If there are no questions, go forth. Take this and see what you guys can do. So I think every group was able to pretty easily come up with the categories, right? We had, what would you call the categories, I guess, is my question. Anybody can feel free to jump in.
Words, algebra, and pictures.
Words, algebra, and pictures. You like those terms?
I like visual better. Visual
I like symbolic. Because they're all algebra.
So visual, symbolic, and verbal.
VSV.
And they're all different representations of the same thing in each row, if you want to think of it that way, or column, depending on the order. Okay. What was a challenge you guys experienced in this task?
We didn't necessarily like that the square was equal to 16.
Say more about that for me.
Yeah.
Because if we just looked at that picture
Which picture?
of the square,
Ah, the colorful picture. Okay, so this is the colorful picture we're looking at. Yep, okay.
we didn't know what anything was necessarily equal to besides those units for 1. and it might be tough to represent that there's 16 of those units in that whole square.
So why was that equal to 16 then?
Was it equal to 16? 12. Good question.
4x minus 4.
Yeah.
Okay. So that was a challenge for you guys to work your way through that?
Made us think twice about why would that one have a 16?
Okay.
Why couldn't it be any other number?
I like it.
I think
Anybody else have a different challenge?
16 is like squares.
Let me turn this on its head. If you were to give this to your students,
Yeah.
what challenges would they face?
Interpreting the word.
Okay, I'll admit it. When I first tried to figure out the 3 x's is that whole 15, and the big 1x is 3 little spaces of the little 15, I kind of mixed it up. I just started. Yes.
Anybody else experience a similar moment, even if it was just a moment of cognitive dissonance in that scenario?
Yep, you see the 3 and the 15, and you just kind of jump to,
You
don't
do.
go together.
And that reminds me of the classic problem. There are twice as many professors as students at a university writing equations. Like everybody gets it wrong because of the relationship is not what we think it is. Okay. So it's not as trivial as we might think. Anybody else, or what might your students have difficulty with?
Ours wouldn't really drive down state diagrams. And I don't think our elementary or lower middle school teachers use that. So they'd have to know what that is. You couldn't just give it. Well, you might give it to them or something because I figure it would be a lot of dissonance. I don't know if it'd be productive.
That's a great question. Like how much dissonance is productive in this case? And we chose tape diagrams because we wanted to introduce everybody to tape diagrams because not everybody had seen them thus far. The high school people would have done some algebra tile work. That might be better. We could have chosen an algebra tile representation piece as well. Was anyone challenged by the verbal category? Or surprised by the way in which we chose to illustrate those?
We talked here about like the wording, what was used. I heard using product, like using different vocab. So like when I did, we each took one of the blank ones and wrote the wording. So I was trying to copy the same type of wording to keep it consistent, but you couldn't. If you did it with students, you could challenge them to use certain vocab. Like here, try and use this vocab word in here, replace what's given, or something like that. Just to extend it a little bit if you want to.
How often do you think your students, when they see an equation written in symbolic form, hear a narrative in their mind similar to what was on the cards when they read the equation in symbolic form? So the follow-up, well, go ahead, please. You were gonna.
Yeah, I don't think that they would have that connection very clearly. And I also wondered, I think because you had asked Jason, it seems like a lot of them were questions. The only one that wasn't a question of what you guys had done was the system of equations is how we wrote it out. And whether or not that was because we think of a system of equations and we try to solve it so that it has one answer. But then I'm thinking, well, that has one answer. The others have one answer for the variable. And just a tangent I got off on.
We brought them back. It's okay. It's okay. Sometimes tangents are useful. It's true. If you were to ask, go ahead.
I was just saying, I think my kids don't think like this at all. My warm-ups are SAT questions from previous SAT questions. So if we have like 3x plus 5x equals whatever, right? I go, how many x's do you have? And they always tell me 2. so that the number to the left tells you how many there are. If I write 3 elephants, so I write 3 elephants, how many elephants do you have? 3. Good. Instead of X, put elephants. Now, how many elephants do you have? We can do that. We got 3 elephants here. We got 4 elephants here. We can add those together. That's what the number on the left means, is how many there are. And when you read it like this, it tells you how many there are. But when you, apparently, when they read the equation, that's not what they read. Every time.
What do you think they normally say in their life?
I don't have any freaking
Anybody else have a guess? I have one. Is this the thing I still say in my head despite the fact that I don't get it?
Like how they would read it?
Yeah.
Yeah.
A lot of just, they would say like 3x equals 15.
3x equals 15 is what they're going to say. They don't think of it as, oh, 3 times something is equal to 15. I can just know the something because it's a multiplication. No, they think, what do I have to do in order to solve this thing? I have to divide by 3 and then...
Without even knowing what that thing is.
Exactly. So my question, like to follow up to that, would be how does the verbal representation and the diagram or the visual representation support students understanding ideas like 3x plus 5x, 3x plus 2x is actually 5x and not just 2x?
I was just thinking a lot of times when I think about this, I think about translating a different language. So the English, which is what I speak, into math, which is maybe not what people speak, you know. So when I say 3, I write a 3, and then I see it times, and I write it times, then I see a what number, so I write that. So I kind of translate it like English into math, but I don't think I do a very good job at making kids translate it from math into English, and that's probably why a lot of times I'm like, okay, what does the number next to a letter mean? And they're like, no, we've never translated that direction, or...
Yeah, that's called applied multiplication, right? And that's a thing that we might talk about once at the very beginning, but then we never really intentionally come back to it. The idea that it is 3 times x plus 2 times x, and 2 times x actually means literally 2 x's. So
One thing that's kind of, that I would think is confusing how the student, the wording that says 1/3, someone could think 1 minus third.
Oh.
And then they go, I don't know.
I saw 2 different versions of this, and I wanted to question, I didn't just because we didn't have time. But you guys have 1/3 times x equals 15 written on your card. There's another card in this room that says x over 3 is equal to 15. And my question to you, verbally, are those the same?
I don't think the way students would think of them are the same. I mean, mathematically they're the same, but I think if a student sees x over 3, they're going to say x divided by 3 or something divided
Right,
by
I
3.
need to multiply to get that x.
Yeah.
They
I
say
think my
bracket,
students
they
would be
have
more
a hard
comfortable
time.
with x over 3 versus 1/3 x.
Because it's what number
Yeah.
divided by 3.
Because you're using the F word in there. You put a fraction. So it is, yeah.
Because it's interesting to talk about, like, okay, fractions is this really big area. But is it possible to, the guess and check method that people enjoy so much sometimes, say 1/3 of what number is equal to 15? It's possible to reason through that and find the answer without doing any kind of algebraic manipulation if you think of it that way. And I would argue personally that x divided by 3 equals 15 and 1/3 times x equals 15. They're equivalent, but they are not mathematically the same. And I think for students the difference is large because they have the F word. Or not.
And it's similar with the language of additive inverses or inverse operations. They're equivalent when you're solving equations, but they're completely different physical movements. So half of your students might get confused if we're saying it one way but doing it the other. Especially when positive and negative integers come into play, talking about taking away 2 from each side or adding a negative 2 to both sides are different physical movements. But sometimes we see them interchangeably, so it could flow out of our mouths or students' mouths interchangeably.
I'm going to give you guys 30 seconds to digest that for a minute. we could keep talking about this all day, and I enjoy the fact that you guys are productively engaging in this conversation on a task that might seem relatively simple to you. Would this be a task that you might consider using in your classroom, something akin to this? Just curious. I like to know if the things that we're providing are useful to you guys. Just a thought. What kind of knowledge did you have to have?
Eighth grade math.
So
I mean, systems would be tough for kids who've never seen
Yeah.
They could get the rest.
Students
They
might
would
go
just know what those
that.
three.
They would know what goes into here.
Right. Yeah.
That
Yeah, I think
That's my confusing.
you have to have faith that the process of elimination was going to work. They didn't put cheap cards in.
I think it adds an extra level of cognitive complexity to the task as opposed to just imagining it. So you have to project it as something that's not there. And I think it would be challenging for students. But I also think that there's enough support in having the other two cards that they could recreate knowledge that they don't necessarily directly have right off the bat before we make this work.
I have all English language learners, so what they can do in math and what they can do in the reading and writing portion is not at the same level. So I have to be really careful which options I gave them. You know, the 3 times and the 1/3, that might be enough to screw up the whole thing just right there. When ultimately they can understand enough to match up the other ones as long as they're not, you know, as long as I'm not just trying to screw with them. If I was trying to get them to be able to read the difference between 3 and 13 or something like that, you know, that's one that would be a better one to start with.
Absolutely.
So it's all about purpose and appropriateness for
Right.
the population.
Right.
And you could modify this task to
Yeah.
accommodate for any number of things. I mean, and in, students who speak a language other than English sometimes have interesting advantages when it comes to working with numbers. Because the way the number systems work in their language is significantly different than ours, and it helps them in some cases. Not always. I mean, because and those are significant barriers. Because you were talking about the 2 registers. Like we have this way we talk regularly in English, and then there's this register we have, the mathematical register, that's the way we use regular English words in mathematics. That's doubly confusing for someone who is not fluent in English as their primary language as well. It's a challenge for those students. And so yeah, you have to be very careful. But overall, at the end of this, end of the day for this, you had to have mathematical knowledge in order to do this task. The tasks I'm about to have you guys do are not going to draw on your mathematical knowledge. They're going to draw on a different kind of knowledge that I think is important that we, and I'm as guilty of this as anybody, that we ignore in our professional development efforts. So here's the thing. If you were to give this list of equations and systems and all of this to students and ask them, hey, could you guys solve each one of these? I would like you to take, I'm going to give you guys 10 minutes, and I actually want you to write this down, the answers to those questions. What strategies might you expect students to attempt to use? What errors might you expect them to make in trying to solve all those equations? And talk about those common errors and try and categorize them a little bit. And then we can talk about the last question as we get through. I want you guys to think about the questions first. What things would you expect to see from students? So before we get
Absolutely.
too deep into answering these questions, does this task feel different than the task I presented you before? Is it easier or is it harder? If you say harder, I want you to think about this carefully for just a second before you answer. If you say harder, what makes it harder? Why is this more difficult than the hard source we're talking about?
Different content area.
Say more about a different content area.
The content we're tackling with those questions are knowledge of teaching students. This is like knowledge of mathematical content.
guys think? Do you agree with that assessment?
My experiences with my students help me with that.
More so than that?
Just learning how to solve that. I would say sometimes it's really hard to, sometimes it's easy, but sometimes it's difficult to anticipate misconceptions. That's when you get to the error question, like what students are gonna do. Like we talked about, same content, but tons of different ways that we can see kids doing this different. Now, if we had now talked together, I didn't think of several of those. So I can't prepare as a teacher when that misconception occurs. If I don't think of all those, it's hard sometimes on the fly, that, in practice, to know how to fix that misconception all the time. Not always, sometimes it's pretty easy to, but having more people talk about those helps prepare how to fix those.
What do you guys think about that?
I was thinking more just like in terms of like being the student and whether matching them up versus like solving them. If I was a student, I would feel a lot more comfortable in matching them. Because it's like, well, yeah, most of the answers here are provided, and I'm just like trying to recognize and apply my information. Whereas if I have to solve it, then it's very like centered on what I can do. Like I'm having to come up with the answers instead of putting pieces together.
Interesting. Did anybody solve it? Like when I said give lists of equations and solve them, did anybody actually go through and solve them as you were trying to think about this?
Huh?
You did.
Well, you asked me to.
No, I
said solve them.
I said if you were going to give students this list and ask them to solve it, what errors would you expect? You didn't have to go through and solve it.
No, you said how would you do it? You said how would you do it? So in order to figure out how I would do it, I had to go through them and do it. I couldn't just do that in my head and go think about what would I do. So when you're talking about what errors might students make, is that when I go through them and I actually do them, then I go, well, what could I do wrong here? Not what could I do right, but what could I do wrong? I do have an advantage because my daughter is a math pathetic. So when I was helping her, she was studying for the MCATs, and I knew that she had no grounding in algebra. If she'd been in my class, she would have failed it. All right, I would have not have passed her. But when she was studying for the MCATs, I spent 6 long weeks doing basic algebra, because you don't get to use a calculator on the MCATs. You have to know how fractions work. You have to know how to solve equations, and she did not. 6 long weeks, 8 hours a day with a girl who had previously never listened to her mother at all. Here's what it was really good for. Every freaking thing that you can do wrong, she did wrong. All right? So if you've got 15 equals 3x, she had learned you divide by whatever's on the left-hand side. Because that's what her teacher had taught her. I go, no, you divide by whatever the x is multiplying the x. She said, we weren't taught that. I go, you've been taught it now, girl, do it. All right? But all of those things, I was like, how can you be, and bear in mind now, she has finished college, right? She has a bachelor's degree. And she has these things which she was taught at City High School, all right? That's what she was taught. And so it's not like she went to some school where they didn't learn anything. She got a 27 on the ACT. She could not do basic arithmetic on anything with an X in it. She couldn't do basic fractions. She couldn't add fractions. It's like, no, we're sitting and doing this. It was a nightmare. I'm not dead yet. She's making $100,000 a year. Woo!
I was your daughter.
You were my daughter? Yeah.
I went through calculus in high school, took my entrance exam at U of M, and was placed in Math 090 because those basics that I was being measured on, I didn't have any idea what was, I didn't know the math.
Yeah.
I was able to repeat after my teacher and just get through. And it wasn't until I started teaching kids with disabilities and with all the learning gaps that I started being able to go through and see, I didn't know this, but it might help when I do this the first time with students to try to build that knowledge base. So,
But that's why I have to actually physically do it.
Yeah.
If I don't actually physically do it and I just think about it, no, it doesn't occur to me. But when I sit and I look at it and I go, I see what else I can do here.
So I'm hearing, I heard three things I'd like to lift out of this short conversation. We're going to continue it, but one, it feels like actually doing the mathematics and thinking about how students might do it wrong is a valuable preparation technique. Two, experience makes all the difference. And related to two, if you can collaborate with more experienced people, you'll get more out of it in terms of your prep.
Can I give you another one?
Oh, no, go by all means.
If you can collaborate with less experienced people, you will get more out of it.
Essentially.
Because less experienced people will also give you a different outcome.
So collaborate then.
Well,
Not even
right,
with more,
because
just collaborate.
last year Carl Shantz was here. She's not coming this year, but he was with our school before, and he was somebody who never did math, couldn't do math. He was in my class for 2 years. He came here for a couple of years. He'll probably be back next year, who knows? But he was so excited by his ability to actually learn algebra. He said, I'm going to go back to school. I'm going to get a degree in math. I want to get a graduate degree in math. Oh, well, you're crazy. But whatever, you know, that's how excited he was. He's down at CC taking classes in math so that he can go back and get a degree in math because he was so excited by it. But he had no math skills. He was like my daughter. It's like, oh, it's Naomi all over again. Could do this. Thank you.
Thank you. Final thoughts?
I would just say sometimes it's hard to think about what strategies the kids will use because we look at it and we already have a strategy we want to use. You know, just like automatic, divide by whatever. You don't think how someone who has never done it or has done very little of it might do.
When I started attempting to make the shift from more traditional teaching to problem-based teaching, and in my grad classes and things, there were two things that were extremely hard for me. One of them was this, anticipating what students are going to do, because I just didn't know. Like, I had no idea. And the other one was this. What questions are you going to ask kids to support their exploration of this task, and support, one, their work moving forward, and two, perhaps get them to confront some of those misconceptions or those errors that they make in a productive way? What questions are you going to ask, and is it helpful to plan those out ahead of time? I'm going to say it is, and that's what I'm going to ask you guys to do, is what questions might you ask them about each of the kinds of errors that you identified, whether you identified them or not? And then what kinds of questions might get students' current thinking out on the table? What kind of questions would you ask to have in your back pocket? When you walk up to a group, you have no earthly idea what they're doing. What are you going to say to get them to get their thinking out on the table and get it published, and you can examine it? And then lastly, the thing about waitressing tables in a classroom for me has always been, when do you leave? And how do you leave? And I always try to leave with a question. So what kind of questions could you ask them so that when you get up and walk away, they're going to be able to move forward? So that's your task for the next 10 minutes, is do some thinking around those ideas. What kinds of questions, let's make it 5 minutes. 5 minutes. What kinds of questions might you ask kids related to one of the areas that you chose? And go into this a little bit.
Negative 5 positive.
Well, no, I'm trying to decide which end I want to put the
is
good
zero?
end. Which end is the good
Do you
end?
want
Yeah.
a big number or do you want a little number?
Great question.
Are you playing golf?
Yeah.
I'm not playing golf. no.
Okay, so
All right,
5.
so big number is good.
How difficult did you find this task, with 0 being not difficult at all and 5 being extremely difficult? Raise your hands, don't be afraid. It's okay, everybody needs to vote. I'll wait. Is that a 3.5, 2.5, or a 3?
Math portion or the evaluating?
The asking questions, like coming up with questions to ask portion. Like this specific task right here, how difficult was this for you?
5 is impossible.
5 is like, oh my God, I don't want to do this anymore, give me an Advil.
Or 3 actions.
Okay, so I'm seeing
You're ranking up
some-
Advil. How much
some ranges.
Oh, okay, so this is the numbers of the Advil.
I'm going to have you guys re-engage with this task after I give you this. This is from I found it's an interesting resource. I've linked it in the slides. It's a 20-page white paper on promoting discourse in the classroom, but the last 2 pages involve sentence stems or question stems that you could use as a teacher to support some of the work that you do. So I'm going to have you guys take the next 4 minutes and read this to yourself. Just read over it and see the categories and some of the questions, things like that.
What they're thinking.
I can't find where it was, but it was something along the lines of, how could you say this in simpler terms? Something like that. So I feel like that was interesting, because I feel like usually it's, how can you use like the mathematical language, but I think that's interesting on how can we say that easier, quicker, faster. So that was interesting.
One of the ones that I often use that I don't think I saw here, I asked, are we finished? Because a lot of my students either stop too soon or they always think there's more to do, and they like had the right answer at step 3 and they've added 4 more steps, which are obviously not right. So that's one I ask all the time, because it causes them, and it's about half and half. And so that's one that I find very.
Another version of that would be, did you answer the question that was asked of you? Like, did you actually do the thing you were supposed to do? So,
Yeah.
go ahead.
A lot of students really react to positive reinforcement. So I carry around a clipboard. I can throw this on here too as a help. I usually have, there's a lot of good questions on here, but I just have it week to week where I just have the name printed off on a sheet. And my clipboard is, if you're not engaged or actively working, I just put a check mark next to your name. And that's every time I come around the room, so you could get one or more. With kids, they don't want that check mark, so even if it's a fake clipboard and you just want to fake it, they'll work harder for you too. And then that's something I can just keep in a folder. I don't give them necessarily grade. I know some people do subjective grading on, that participation or whatever. I just keep it as a reference so that, they get a lot of check marks next to the name. They're not really working in their group setting. But you bring that around and you give a check at a group of 4. I don't care what grade level it is. They all wonder who got the check. I'm the other one who knows. So.
And in the end, it might be a useful record-keeping thing to initiate a conversation with the kid about, hey, like, I noticed the last 4 days, nothing's been, what's going on? Why?
And it's a nice conversation when you piece with a parent if you're emailing, like, they're working in class. Well, they had 12 check marks this week, and stuff like that. So I'm just saying, you could throw this on here, but you look more professional or something doing it. You can fake them out.
And I don't think there's anything wrong with carrying around a thing that supports you and asking good questions, solid questions that aren't the usual patterns that push students into the same solution sets and the same solution methods all the time. That's really hard to do and do well. And so there's no reason not to have a resource to help you out.
We have some middle school teachers that are using their iPhone now because there's an app. They said the name the other day that they're using, and it makes a little sound when they go around to the groups. And so I don't know the name of it, but it's the same thing. Like when they come around the group, they just hit a button and it goes like that. And then one of the 4 know that they got a check mark, and somehow that's tied into their grade book too. It can go in there.
Interesting.
Yeah.
I wonder if it's fair to characterize that as positive reinforcement.
But it does a happy sound once in a while.
Yes, positive, you can pick the sound again.
Yeah.
So, in an effort to get us on to doing your things, this is the resource I just gave you. The full resource is linked in there. I put it in the Google Drive folder so you guys have access to it. So here's the research that Mike and I were looking at to kind of talk about this, right? And we realized as we were having our conversation about what we were going to do today, we've spent a lot of time over here in this subject matter side, because Mike and I are math geeks. We love to do math, and you guys seem to engage with that as well. And so that's been kind of useful because it's always an opportunity to increase our content knowledge. Specifically, like there's this stuff, right? There's common content knowledge, which is just the stuff that everybody's supposed to know. And then there's this stuff, which is what we've been working on, which would be like knowing how to create a tape diagram representation of an equation is an example of specialized content knowledge. It's not something you normally need in order to survive life. It's not mathematical knowledge necessary for teaching. But like you said earlier, knowing what kind of errors students are going to make and knowing what questions to ask them to advance their understanding, they don't fall on this side. They're not over there. They're over here. And so Mike and I decided to engage you guys a little bit today in those other two domains, specifically this knowledge of content and students, which is that first thing you guys did, which is anticipating students' errors. Like there's research out there that kind of categorizes very common errors for very specific kinds of things in algebra and functions and things like that. And so there's ways to look at, like, the errors are not entirely random. There's a limited number of them that actually happen, and they fit into some nice categories in the end. And then knowing what questions to ask kind of fits under here. Like knowing which question to ask and how to ask it at the right time to get a student to move forward is this other domain. So we try to engage you guys a little bit in this other domain. I have a handout for you that talks more about this if you're interested in it. It's not necessary for our conversation today because we're done at this point except for my challenge for you guys, which is the following. Between now and next time you meet, I would like you to try to go through one single lesson without ever answering a question from a student. Now, you're allowed to answer a question with a question, but you're never allowed to tell them anything. Just a challenge for you. Try it. See what you can do.
Lesson without answering?
One lesson without answering a question by telling them the answer to their question.
Oh. My complaint that I never answer questions.
And that's good. Like that's what we want is like ask those annoying teacher questions, but just see what happens. Challenge yourself. And that's it for our portion of it. But I do want to remind everybody that we are. Well, there's our collaboration. Collaboration is always better.